Hey everybody, so in this video we're going to be talking about how to find the exact value of tangent of 255 degrees. So like in prior videos, the reason that your sum and difference identities are so convenient is because we can evaluate at degrees that are not on the unit circle. So it's really easy to find tangent of 30 degrees, 60 degrees, 45 degrees because these values are on the unit circle. But when I have something like 255, it's a little bit more cumbersome in order to find that exact value. But what's nice about the sum and difference identities is that we can use values from the unit circle to generate what tangent of 255 would be. So what we're going to do is we're going to pick 2 degrees from the unit circle that would add together to give us 255. So the two that we're going to use in this video are 225 and 30. So we could rewrite this here and say tangent of 225 plus 30. That's going to give us 255. So we'll go ahead and plug our values into this equation. So we have tangent of A. We will say this is tangent of 225 plus tangent of 30. We'll put this all over 1 minus tangent of 225 times tangent of 30. Now, when you're evaluating here and you're having to do this without a calculator and you're using the unit circle, you have to remember that tangent is sine divided by cosine. So you would use the y value from the unit circle and divide it by the x value. Now this can get cumbersome, and there's a nifty little trick with right triangles that we could use where we don't have to do that. 225, if I wanted to draw this angle in a quadrant plane, so if I came over here and I said, okay, here's 225 degrees. So I know this is a small triangle. You know what? Let's move this in yellow down a little bit so that we can make this triangle bigger. Okay, there we go. So now if this is a 225 degree angle right here, this reference angle is going to be 45 degrees. So in a 45-45 triangle, we know that the two legs here are the same length. So if we're in the third quadrant, that would make this -1 and this -1, because in the third quadrant, your x's and your y's are negative. And then my hypotenuse is going to be the square root of 2. Now I can draw a 30 degree triangle, and I'll draw that over here. So here is a 30 degree triangle. So this is a 30, 60, 90. So remember, across from 30 is 1, and then across from the 60 degree angle is √3, and then across from your right angle is 2. So when you were learning about this in geometry, you learned that the short leg was x, the long leg was x√3, and then the hypotenuse was 2x. Here we're just saying that it'll have a height of 1. So now evaluating at 225 is going to be much easier because with right triangles, tangent is just the opposite leg divided by the adjacent leg. So tangent of 225 is going to be -1 divided by -1. So here we have +1 plus tangent of 30. So if I come up here, tangent is opposite over the adjacent. So this is going to be 1 over the square root of 3. And then in the denominator, we have 1 minus tangent of 225, we've already answered that. We did it here. That answer is 1 times tangent of 30, which we've already answered, 1 over √3. So here we have 1 plus. Now, you can leave your answer like this. Technically, that's the correct answer, but your teacher or professor is probably going to want you to simplify and then rationalize your denominator. So that's what we're going to do here. So if I rationalize this, I'm going to have to multiply it by √3 over √3, and that's going to give me √3 over 3. And then I will divide that by this denominator, which is 1 minus √3 over 3. So here, this is technically a more accurate way where you could write the solution. And what we're going to do now is we're going to rationalize the denominator. So we would need to multiply by 1 plus root 3 over 3. And we have 1 plus root 3 over 3 here. So here, this would give me 1 plus 1 is, or excuse me, 1 times 1 is 1. And I'm going to say 1 times root 3 over 3. So I have root 3 over 3 plus root 3 over 3 times 1 plus, this is the square root of 9 over 9. And this is all going to be over 1 times 1 is 1. 1 times root 3 over 3 is root 3 over 3. Negative root 3 over 3 times 1 is just negative root 3 over 3. And then here, this would be a negative or a minus root 9 over 9. So we're out of room here. We'll go to the next slide, and then we'll continue. So here's what we brought over from the previous slide. So we're going to pick up from here, and we're going to start simplifying. So we have 1 root 3 over 3 plus root 3 over 3. This is going to be 2 root 3 over 3 plus, and then the square root of 9 is 3, and 3 over 9 is 1/3. This will all be over 1. Positive root 3 over 3 minus root 3 over 3, these go away. And then we know that root 9 over 9 is 3 over 9, which simplifies to 1/3. So this is 1 minus 1/3. And now here, these both have a denominator of 3, so we could change 1 to 3 over 3, and then we could add all the numerators. So we have 3 plus 1, this is 4, plus 2 root 3, this will all be over 3. And this is being divided by this denominator, 1 minus 1/3. So again, we can change 1 to 3 over 3. 3 minus 1 is 2, so this is being divided by 2/3. Remember, when you're dividing fractions, you have to keep the first the same, change the division to multiplication, and then flip the second fraction. So this would be 4 plus 2 root 3 all over 3 times 3 over 2. Here, these 3's cancel, and I'm left with 4 plus 2 root 3. This is all over 2. And here, your 3 numbers are all divisible by 2. So I could divide each one by 2, and that's going to give me 2 plus 2 divided by 2 is 1, and this would be plus 1 root 3, but we really don't have to write 1 as a coefficient. So we're going to say 2 plus the square root of 3. All right, that's going to be all for this example. I hope you found this video helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.